Otherwise, we would like to move to our next speakers from Greece. She is working in a Greece ministry, Dr. Ranina Lampou. Dr. Ranina Lampou is here.
Yes, I'm here.
Thank you.
For
Thank
great
you, Dr. Ranina
things.
Lampou from Greece. We are very grateful. You gave us your valuable time and make a participation in international summits on a quality education, SDG 4. Thank you. Thank you once again. Thank you.
Warm greetings from Greece. I would like to thank all organizers of Rohan Institute of Higher Education for setting up this very significant conference on sustainable development goals. I'm a STEM instructor, researcher, and today I will going to present how STEM education can be combined with sustainable development, because STEM is a new trend in education. It has been integrated already curriculum in many countries, and as I always say in my presentation, it's the future of education. So allow me to share my presentation. I don't know if it's, can you see now it's visible?
Yeah, sure. We can see your presentation.
So STEM education, science, technology, engineering, mathematics plays a critical role in promoting sustainable development. In this educational approach, not only equips students with technical skills and knowledge, but also fosters problem-solving abilities, critical thinking, innovation, all essential for addressing the complex environmental, economic, and social challenges of sustainable development. Sustainable development, of course, contribute to developing competencies in sustainability, as I said before, collaboration, systemic thinking, and sustainable development. It's actually this development that meets the needs of the present without compromising the ability of future generations to meet their own needs. There are 4 pillars of sustainability: human, economic, social, environmental. And STEM is the way to secure a strong economy and capable workers, because it focuses on open-ended real-life problems and requires student-led investigation, hands-on activities, and this helps students to become out-of-the-box thinkers and creators. This reflects the 4 C's: collaboration, creativity, communication, critical thinking. And the characteristic of STEM educated students is that actually they are inventors, they are innovators, they are logical thinkers, they're technologically literate. And of course, the 2030 Agenda considers education as a key strategy to accomplish important environmental goals. So education must answer the environmental issues, defining new objectives, relevant objectives and contents. We need new global frameworks and specific teaching programs in order to empower the people and students. So from this point of view, educational institutions have to establish new educational programs to create an essential context in order to integrate sustainable development goals. So achieving these goals, first of all, we need to say that STEM learning is something that should be a lifelong process. When students deal responsibly with technology, learning should include everyday experiences, and of course, broader sociocultural, political factors should be considered. Already, according to UNESCO, advances in STEM have brought about significant improvements in all aspects of life, in health, agricultural, infrastructure, and the skills acquired by STEM education are referred by World Economic Forum as a measurement of the future preparedness of the countries. So how STEM education can contribute to sustainable development? First of all, we see that achieving the goals, achieving the goal to overcome the challenges, they necessitates a shift in STEM education away from a focus on academic technical knowledge towards a much broader interdisciplinary complex problem-solving approach that combines societal and sustainable problem analysis with academic technical knowledge and solutions. So STEM students need to learn how to analyze and solve a complicated and complex problem and be able to collaborate in a variety of teams. So steering STEM education in this direction will require, of course, educational leadership and research. Curriculum change should be approached in a systematic way, which includes promotion and faculty development. For example, how is engineering sectors changing? Engineering students need to learn how to analyze and solve the problems faced by the society and to develop technologies that will improve sustainable living. These needs are reinforced by major trends shaping STEM education, like emerging technologies, the employability agenda, as well as diversity issues, etc. So, first of all, developing sustainable technologies, because STEM education encourages the development of solutions that can help mitigate environmental impacts. For example, engineering and technology students can work on renewable energy projects, water conservation systems, sustainable agricultural techniques. Promote environmental awareness because students gain a deeper understanding of ecological principles and the importance of protecting natural resources. So this awareness can inspire future leaders to prioritize sustainability in various sectors. Of course, innovative problem solving, because we need to come up with innovative ideas for addressing sustainability challenges, such as climate change or pollution or resource depletion. And for example, engineering design projects can focus on creating efficient energy systems or reducing waste in manufacturing processes. Interdisciplinary learning, of course, STEM, it's about a transdisciplinary approach, a holistic approach, requiring knowledge across different fields. And this brings together principles from science, technology, engineering, mathematics, and other fields, allowing students to approach problems this way from multiple angles and develop holistic solutions. Preparing a skilled workforce, because a strong foundation in STEM fields prepares students for careers in industries that are pivotal to sustainable development, such as renewable energy, environmental consulting, urban planning, and sustainable agriculture. So these sectors require a workforce equipped with technical skills and a sustainability mindset. Encouraging responsible citizens, because students learn about the impact of their actions on the planet and society. This leads to a more responsible consumer behavior for an advocacy for sustainable practices and active participation in community initiatives. Of course, it fosters global competence. And this requires international collaboration. Some examples of STEM initiatives for sustainable development: first of all, green chemistry, when we educate students about chemistry practices that reduce, for example, or eliminate the use of hazardous substances, or hands-on projects in solar, wind, and hydropower, which actually teach students about clean energy solutions. And sustainable engineering, when courses and projects focused on designing buildings, systems, and products that minimize environmental impact. So STEM education, it's not about teaching technical skills. It is also about instilling a sense of sensibility, of responsibility, and innovation that is crucial for achieving sustainable development. By integrating STEM sustainability into STEM curriculum, we can prepare future generations to tackle the challenges of the 21st century with creativity, knowledge, and a commitment for a better world. How now extracurricular activities, for example, STEM clubs and competitions, international competitions. Here in Greece, we have many winners. We have students who are winners in international Olympiads, and this is very important. These activities play a significant role in promoting sustainable development education by providing practical, hands-on experiences that complement traditional classroom learning. And these activities offer students unique opportunities to explore sustainability topics in depth, develop critical skills, and engage in real-world problem solving. First of all, STEM clubs and competitions, for example, allow students to apply theoretical knowledge to practical challenges, hands-on approach, so they can understand better renewable energy or waste management, environmental conservation. You can implement many projects, for example, waste management in school, inside the school institution. Innovation and creativity, because these activities provide a platform for students to experiment with innovative ideas, interdisciplinary learning, skill development, raising awareness, real-world impact. This is very important. For example, a competition might involve designing a cost-effective water purification system for use in underserved areas. So these projects not only enhance students' learning experiences, but also contribute positively to society. And of course, encourage lifelong learning. because students can pursue further education and remain engaged in these issues as informed citizens. So what are the recommendations? Since we have said that these extracurricular activities are vitally promoting sustainable development education, they provide experiential learning that help students address and understand real-world challenges, encourage innovation and creativity, and foster skills and values necessary for advancing sustainability, means that we need to improve and strengthen STEM education in school. So there is a need, of course, to integrate the topic of sustainability into the curriculum in order to ensure that all learners acquire the knowledge and skills needed to promote sustainable development. Here in Greece, we have integrated with a new reform in our curriculum, environmental awareness as an optional thematic session, and it's a great reform for Greece. So interdisciplinary sustainable development employability STEM curriculum, so governments need to increase the focus on the disciplinary curriculum on professional competencies, combining with funding models that support these needs. Maybe national accreditation criteria should be formulated and accompanied by incentives and rewards for institutions meeting these requirements. Of course, investment in STEM studies and institutional change embracing complexity. These include how to change, how to redesign the curriculum and learning approaches to the creation of comprehensive blended educational models developed in cooperation with industry and other societal factors. And such models make use of real-world complex problems and projects, including with reference to sustainable development. Of course, educational leadership for educational change, we have seen here already this recommendation how to strengthen all types of STEM capabilities, how to expand, innovate STEM education globally at all levels of education, higher education also, establish diversity STEM systems, encourage young people, develop sustainable professional STEM organizations to support STEM education, especially in higher education institutions. So all this has to do with what we call education for sustainable development. So environmental education, and this actually what is important because the aim here is to empower students to participate in shaping a sustainable future. This means this promotes a sense of place of connection, promotes citizenship, active learning, student leadership, because it empowers students to share their voice and make a difference. And this, of course, is characterized by contextual and locally relevant learning, because we take students and go outside to the nature and we implement environmental projects. This way, students can adopt more healthy lifestyles and they learn how to love nature and environment. So this kind of education should develop individuals' values, knowledge, skills, and competencies for sustainable living, and it should promote, of course, critical thinking, encourage participation, collaboration. It should be interdisciplinary, holistic, value-driven, and of course, this has to do with a democratic, inclusive society in which environmentally literate community members possess the sense of agency and empowerment and responsibility. So this offers a vision, environmental education that makes sense. And actually, when we talk about education for sustainable development, this always entails environmental literacy. Environmental literacy depends on learners' ability to ask questions, to seek information, to observe the nature and make hypotheses. So learners must be familiar with inquiry-based learning, master fundamental skills, interpret, synthesize information to develop explanations. So we have a set of skills, questioning, analysis, interpretation, how to collect information, organize, how to work with models, simulations, of course, here students develop an understanding of how changes in one system results in changes in another. Environmental literacy includes the abilities to define, to learn about, to evaluate, to act on environmental issues, how to identify, investigate issues, how to sort out the consequences of issues, how to work with flexibility, creativity, and openness, how to develop decision-making action skills, so plan and take action, how to rights, responsibilities, recognize efficacy, accept personal responsibility. Some examples here of this, of how we can combine STEM education best practices with STEM in school. Here, sixth grade students measure temperatures in air compared to the carbon dioxide to understand the greenhouse effect and the foundation of climate change. They use scientific database about cities. They come up with solutions, explore also thermal inversions, etc. So many of these cases, I don't have time to see all this. Here are some of activities of my students of STEM actually a project. This project is called the contribution of technology to the protection of our health. It concerns the quality of life of residents of large cities, where the common type of living is an apartment within a large apartment building. So in this project, we examine the nuisance factors of an apartment, and more specifically noise pollution, the harmful factors of the gaseous environment of the apartment, such as carbon monoxide, smoke, and dust. So a miniaturized model of the apartment was constructed, and sound detection sensors, as well as carbon monoxide detection sensor, was installed within it. So STEM technology we used was a Arduino microcontroller, connection board, LEDs, data, etc. Display. And apart from this, here in the Greek ministry where I'm working, I have launched an environmental project which combines STEM education with environmental education at art. It's called SOS for Changing the Earth's Climate. Its focus is on 5 sustainable development goals. The thematic axis concerned, of course, all this how anthropogenic and natural factors that affect climate change in place. Children through this project had the opportunity to get acquainted with various ways in which humans affect the earth. They have the chance to realize their own involvement towards climate problems, to solve already problems, to be involved in exploratory discovery learning methods and approaches. They can experiment, they can collaborate, they can cultivate their creativity, and of course realize that we all have responsibility to promote the Earth's climate. Some examples of activities we have waste management activity, replantation, building a mini meteorological station, measurements of temperature, pressure, and humidity, experiments to simulate weather phenomena that occur in Greece, and maybe extreme weather phenomena. And this project, of course, through this project, students already, I forgot to say that this is implemented in primary education because it's important at an early age, students should be they should deal systematically with scientific environmental issues at an early age. In this way, they can enhance their ecological consciousness and environmental responsibility. Apart from this, I'm the founder of several projects in the national project based on sustainable development goals that have to do, first of all, with water awareness was implemented in Malawi, Kenya. Food for thought, how to teach food combination, case of food shortage was implemented in India, and many others. So thank you very much for your attention and for any question I'm here to discuss.
Yes, I have. Yes, I have a question.
Yes,
if I may
yes.
be attended. Oh, yes. Thanks so much, Madam Ran. Yeah, glad to hear everything about we discussed concerning to this about STEM. It's purely, really, it gives a very strong recommendation to the public as well. We are now going to globally phenomenon. Yes, about STEM. Now, I noticed that under your recommendation, you have just mentioned about investment in studies, right? Now, I just want to get to know from your end about the right perspective. How about those countries who are not yet gaining a full control, economically speaking, politically, and of course, it affects so much about the education system. How do they reinforce? Do you have any alternative recommendation solution for these things so that they will come up a clear and a concise, projected situation analysis concerning about this STEM? That's my question,
Yes.
ma'am.
Yes. I guess you are asking about developing countries or countries that do not have the possibility to have the equipment, technological
Precisely.
equipment. Okay. Okay. In Greece, for example, there was this case. I mean, when we started STEM education, there was no possibility for technological equipment. But we implemented gradually the national competitions. So the national competitions need the collaboration between private and public sector. When companies and industries are involved, what is happening? They give the infrastructure, the equipment to the group, for example, robotics group
yes.
for the competition. So the robotics equipment stays there, the school. So during this pilot period here in Greece, this will happen for 2-3 years. And now all schools, almost all schools have this technological equipment.
Oh, yes.
This means that we need to encourage students in order to participate in the national competitions, hackathons, when we invite young people, for example, to invent innovative solutions, patents, for example, to give solutions to use device Arduino Raspberry in order to invent, for example, something that could help to tackle climate change. Then we select the best ideas, and these ideas are taken and valorized by industries, and they become products. So you can understand that we need investment needs a collaboration with the private sector and industries and companies. However, there is another type of STEM, there is STEM unplugged, and again, if in developing countries we don't have the possibility to buy this equipment, again there is another option, STEM unplugged. You can show physics, for example, principles with a very nice project, hands-on activities that could use only cardboard and water, things like that. Again, there is an option. What I'm going to say that if you want to use STEM, and this concerns all subjects, it's not only about science and technology. You can use STEM even in history, even in English language teachers. This STEM, the magic of STEM is that it breaks down the barriers between cognitive disciplines. You can use it in every discipline. And until again, if you don't have the possibility to buy the equipment, again, you can go for STEM Unplugged. STEM Unplugged doesn't need program or coding. You can do it with simple everyday materials that you have in your classroom.
Oh, yes, thank you. Thank you, Mama, so much for that. Anyway, I do appreciate about how you answer everything about all these things, but one thing that comes to mind, particularly concerning, there must be a collaboration between the public and private partnerships so that we will come up a clear and concise type of project plans and program in order for us to reach the ladder of success when it comes to investment in STEM studies. That's all. Thanks so much, ma'am, for this
yes, and
inquiry
recently,
that I made and you answered me.
Exactly. Recently in Greece, we have for the first time industrial PhD industrial. So industries invest in PhD proposals that are innovative. So for the first time, we have the participation of industry.
Oh, yes, thank you. I'm fully aware of all these things about how you share. Thanks so much, ma'am.
Yes, thank you.
Buena nga sulusahon. Nagita ta. Ito kakit-kit. Ngan adlaw to. Yon ping camera ko usang pag-present pag-workshop. Workshop kanta.
Living to bala, sir.
First time.
Advisory ko. Nagbigad tayo sa
Sabi
class ng
ni
June 25 kaso hindi sir. Ako ano ang target naman. Di ba sa kubag ulan naman na ano, kung na SOP.
Ay, naman kasi boss. Saan sila?
Dating ito yung parang kita maglibat ng bat. Equally sila, sir.
Nagkamit
Yes, sir.